Okay, so here is it again, the famous normal distribution. Bear with me, got to get my paper. Got to get, might as well do that little extra, getting some more paper, get my pencil, almost ready to go. Moving the paper up, doing some of the standard procedures that we've been doing lately at least. There we go. And now the title, normal distribution continued. Distribution continued. More about that. Here comes this curve again, but now we're going to do a better job of explaining. Since it's a new paper, I'm going to just call it problem number 1. Here we go. Let me try to do a better job of even drawing. That's not too easy for me. It's something like this, and it's supposed to be everything's supposed to be symmetrical on the right and left hand side of the mean. Okay, so here's the mean. The mean is where the average is. And what happens over here is approximately over here. Of course, I can't draw it very well, but this is going to be the mean plus 1 standard deviation, and the standard deviation is going to be an S. Okay, how many people fall if you're just doing the heights of everybody in the world? And that would be a normal distribution of an event in the world, of a phenomenon in the world. So there is basically 34.1%. I don't think you're going to have to ever memorize this for a test. I don't think so. This is supposed to be an S. Okay? Now, a little bit further down the road, down over here, again, and it's not going to be very proportional. My graphs are not going to be that good. That's in 2 standard deviations away. 2 standard deviations away. And what you have over here, in between here and here, in between here and here is 34, in between here and here is 13.6%. 13.6%. And then when you get just one more, we're not going to go further. And this gets closer and closer to 0. But anyway, about, let's say over here, here is standard deviation plus 3, mean plus 3 standard deviations. And between here and here, you're going to get 2.2%, 2.2%. And the rest of the way, which is going to get smaller and smaller, this is going to go on and on. You're going to get 0.1%. In here, you're going to get 0.1%. Very small amount of people in it. If you're talking about weights and someone's 500 pounds, there's going to be very few people that are 500 pounds. And it's symmetrical, so it's exactly the same on the other side. But this would be in minus territory. This will be the mean minus a standard deviation, 34.1. This will be this area over here will be 13.6. And now we're arriving at the standard deviation, this mean minus 2 standard deviations. Finally, you get over here, and it's the mean minus 3 standard deviations, minus 3 of them. And here you're getting over to the same 2.2 you see on that side, 2.2%. I'm not bothering with the percents over here. I wrote them on the right. I'm not writing them on the left because it's hard to get the room. And then this will be the same old 0.1 when you go the rest of the way, 0.1. And it gets smaller and smaller as you go. Okay, so now that's what this looks like. Here's an example of a question. If we ask you as follows, let's say that the average height of men in America, let's say the average height of men in America, that's the mean, right? The famous word, the mean, is, let's say it's 5 feet 9.3 inches. 5 feet 9.3 inches. Okay. Now, the standard deviation, this is also given, right? So this is given. All this is going to be given. Given. The standard deviation is equal to 2.8 inches. All right, here's the question. Here's the question. Thousand men picked randomly. Okay. How many would you expect? How many would you expect? Would you expect to be between 5 foot 6 point inch, 5 feet 6.5 inches and 6 feet and 6 feet 0.01 inches. Okay, so this is, you might accuse the book or me or whatever, wherever this came from, of being a trick question. You'll see in a second. It's going to be easy, but it looks a little strange of how you're supposed to get this job done. So let me show you. Notice as follows. What is the mean? The mean is 5 feet. The mean is 5. The mean is equal to, this is scrap paper work, okay? We're hashing it out. The mean is equal to 5 feet, I forgot that T, 5 feet, 9.3, right? Now, where is 5 foot 6.5? If I subtract 2.8 inches, right? 2.8 inches from these inches, you will get 5, that's why it's a little bit of a trick question. You will get 5 foot 6.5. That's where the question is asking between these two things, and they chose it on purpose. That's actually one standard deviation away from the mean, behind it, to the left. All the stuff, the lower than the mean is to the left, and all the heights that are higher than the mean are to the right. Okay, so they chose something that turns, and now let's examine 6 foot 09. So let's take again the mean, 5 feet 9.3, and let's this time add 2.8 inches. 2.8 inches. What will we get? That we're going to get 1 inch over here. 3 and 8 inches is 1 inch, right? 3 and 8 inches is 11. I'm sorry, is 1. And then we've got 1 inch. But what are we going to plus another 10, and we're going to be adding 2 inches to this. I'm sorry, we're going to have 1 inch over here. 3.8 is 1. We're going to have 1 inch, and 9 and 2 is 11, and one other inch, right? 3 and 8 is 11, so 1 here, 1 here. 9 and 2 is 11. 11 and 1 is 12. How much is 12 inches? A foot. So it's going to turn into 6 foot and 1 inch. And there, they chose this on purpose. They chose both of these on purpose. So this is 1 plus a standard deviation, and this one is minus a standard deviation. Look over here. If you go up a plus standard deviation, you're going to have 34% approximately, right? So, and if you look at minus a standard deviation, 1 standard deviation away from the mean, which is the mean is 5 foot 9.3, you're going to have another 40%. Add those two together, and 68% of the men, 68% of these, approximately 68% of these 1,000 are going to be in this range, in between these two. So the answer is 68%, this 34%, and that 34%. A total of 68%, approximately 68%. We could say 68.2%, but 68% is probably good enough. A good enough answer. Good enough. And maybe they'll want 68.2% to be exact. Okay, so that is how to take care of this problem. All right, so if you would take the 68% times the 1,000, if we take 68% times 1,000, times 1,000, right? 60 of 1,000 is going to be 0.68 times 1,000, which is 680 men. So that's the other way that they could say they want their answer. Answer B could look like this, or answer B could look like this. Okay, then we'll stop this video and move on to the next question.